Hello all, today we are solving LeetCode problem number 712, minimum ASCII delete sum for two strings. So we are given two strings, basically string 1, S1 and S2, and you can delete the characters to make S1 and S2 equal, right? So what is the output which is to be returned? So we have to return the minimum of sum of deleted characters to make S1 and S2 equal. Right, so let us understand this problem by running through the example 1. So we are given basically S1 as SEA and S2 as EAG, right? So here in the explanation they are given deleting S from SEA adds the value 115 to the sum, right? So we are deleting this, and probably we'll be removing the T from here. So yeah, so based on this we are getting 115 and 116 added, and which will give the minimum sum as 231. So we have to return this minimum sum. So this is about what exactly we have to return. So there are some more possibles, like other than EA to be so we removed S and T from here in such a way that S1 has EA and S2 has EA, so both are equal. Similarly, we can have E alone and A also. So in this case you have to add 95 with 231 for this case to count the sum of deleted ASCII values. And similarly here we have to add 5 more, which is 101. Yeah, so here this will be 231 plus 101. So this will be the answer. So comparatively we are the minimum value is 231, so that is why we are returning this particular answer. So let us understand with further example. S1 as delete and S2 as lead. So in this case this will be in the question only. So here you can see you have S1 and S2 as delete and lead, and the output expected is 403, right? So let us go through this problem and understand what exactly we are doing, and let us come up with the observation from going through this example. So we can make let from both by removing DEE and one more E from here, right? So we are getting let from S2 and let from S1. So we are having DEE, so which is 100 and 101 and 101 and 101, which is 403, right? So similarly the next possibilities can be LEE and LEE, right? And the next one will be removing this L. It can be EE and EE. So in this case we are removing DE, then T and T. So DEE is lesser than DEET, because here there is 2t, basically, I'm sorry, 2t, which is which the ASCII value of t is greater than E. So because of that this will be the smaller one, and comparatively here we have to add L also here, right? I think because of that we this particular let will be the string, and DEEE will be the string which we are removing from both the deleted characters, right? So the ASCII value of this will be 403, and hence we are returning 403. So from these two example, what are all the observation we are noting it down, right? So let us note down the observation. So from this we can say that there is no jumble operation being performed, meaning that uh, we are not choosing D and E jump where the index we are not performing by jumble operations, right? So we cannot perform no jumble. It should be processed in the linear way, left to right. So we cannot jump from one to the other to make sure the string is equal, right? So no jumble available. And then we can see clearly three operations, right? Because if you process here, uh, delete and lead, let us have I here and j here, right? And these two are not equal, so we have two options. Either we can delete this or we can delete this. So we can delete uh, from s1, oops, s1, and delete from s2, right? And there is one more case. So if both I and j is in position where I and j are equal, there is no requirement for deleting it, right? So directly we can jump to the next index, right? So one more operations, which is if s1 of I equal to s2 of j, you can directly jump, right? Jump to the next index, right? So these are all the operations which we can do, and this we are writing down in the observation part. And let us understand this by performing the recursion tree, and so that we could come have a further more clear cut understanding before jumping into the coding part. So we are given delete and lead, right? So let us have I pointer here and j pointer here. So as you can see now, uh, the position where I is there and the position where j is there, we have two different characters which is not equal. So we will be performing any one among these two operations, right? So we have two operations, which is delete s1. So we can delete the e, so e will be here, e plus, and the I will be incremented to the, I mean jump to the next pointer. So I will be here and you have lead here. And similarly you will remove t from here, so t plus delete, and here it will be lee. And if you, and here you can see both the characters are same. So because of that, if it is same, just jump to the next index, right? So that is what you will do. So the e will remain same and you have delete and lee, I and j. So let us expand this further. Similarly again it's still the same. So e plus del and le, and now you can see there is a difference. So there is two ways. Again, you can remove from s1 or s2. So in case of s1, this becomes el plus de and dle, and this becomes EE plus DEL and D. Oops, it's L, it's not D, it's L, right? So, and further we can expand this for completing this quick, and here we can see that 2 has L, so that we can jump to the next one, and it becomes EE plus DEL, oops, DE, and this becomes empty, right? So this becomes empty, so this will be the base case. So when this becomes empty, we have to, what we have to do is we have to add the remaining one, whatever is remaining, whether it is from S1 or if it is S2, we have to add it with the characters whichever we have deleted, and we have to return it. So this becomes D E E E, right? So similarly, every tree forms the nodes, and the leaf nodes, and the leaf nodes hold all the characters which can be deleted to form a particular string. And now what we have to do is we have to calculate the ASCII value for this and find minimum among all these one, and we have to return it. So we get the base case here, right? And also we get the operations, the if it is same we have one operation, and if it is different we have two different kinds of operations. And also we can track this by we have two basic operations where we can delete it and track it, right? So based on that we can use that particular operation for tracking it. And these are all our observation, and let us go ahead and code this up. So we are solving using dynamic programming only, but we are using memoization. So here I will be using LRU cache to reduce the coding and finish this off soon. But there will be some time complexity issues because of that. But yeah, so let us go ahead and code this up. So we have to define the function, and LRU, oops, LRU none, right? We can also use hash map, name the hash map, and you can save the value whichever we are getting out of the DFS through the map, and we can use that, which will give better which will be a better solution compared to this. But yeah, so base case, so if I equals to length of S1, we are returning a base case, and also if j equal to length of es2, we are reaching a base case. So here we have to calculate whatever there whatever characters we have separated to delete it, and whatever remaining characters we have to submit, right? So because of that we have to return sum of, we use odd function to calculate the Unicode values or ASCII value of the characters. So v for v in S2, since S1 is empty, we have to take every string, every characters from S2. So because of that, here I'm performing the slicing operation to extract all the string all the characters, and loop it, and using ORT function calculate the ASCII value and sum it up and return it. And similarly return sum yes for yes in yes1, and slice that fully, right? And we have the recursive condition 3. So if yes one of I is equal to s2 of j. In this case you have to just jump, so the recursive call will be return dfs I plus 1 j plus 1, right? And there is that two conditions, so there we are deleting the characters and we are counting it, counting the ASCII value, right? So we have to store that to compare it. So because of that, so delete s1 is equal to an s2, so this is equal to, you have to calculate the deleted one, right? You choose one character from s1 to delete and other character from s2 to delete. So because of that, that particular index will be consumed, right? So s1 of I, and you sum that with dfs of, you perform the next recursive call jumping to I plus 1 where a j remains the same, right? So I plus 1 and j, and similarly this will be s2 of j plus dfs of I and j plus 1, right? So now we have to return minimum among these two, so minimum among s1 and s2, right? And now call the recursive call, so dfs 0 0, yeah. And this is not a very efficient solution, but yeah. So for the time complexity will be order of n cross m, where n is size of s1 and m is size of s2. Since we are having two strings, we are processing two strings, the time complexity is order of n square, sorry, n cross m, and similarly the space also remains order of n cross m. So that's it for the video. Thank you.